I'm going to show you a couple more things that you can find on a velocity time graph. So in this video, I'm going to show you how and why you can find that the area underneath a curve on a velocity time graph is equal to displacement. So the area under the velocity time graph is equal to displacement. This graph right here is showing us that an object goes 6 meters per second for 5 seconds. That's the interval of time, and the velocity is 6 meters per second. So in a physics problem, the displacement, you'd find the displacement by taking our velocity equation and solving it for displacement. So you'd have displacement equals velocity times time. And in this, if this were our problem, our velocity is 6 meters per second and our time is 5 seconds. And seconds would cancel each other out and you'd be left with meters. So you have 30 meters is your total displacement for this motion. This is equivalent to finding the area underneath the curve, because area is equal to length times width. So if this was our shape right here, it's a box, conveniently for this video. It's not always a straight line. But so we have length times width is equal to 6 meters per second times 5 seconds. And that would give us the same thing. It gives us 30 meters. Okay, so that's why length times width, or the area under a velocity time graph, gives you displacement. If you see a graph like this, it's a curve, and you have to find displacement under it. For our class, and I guess for most purposes, you could break it down into boxes. Oops. So you would find the area by breaking this graph or this curve down into boxes like this, and then finding the area of this more boxy shape versus trying to find the area underneath that curved line. So if you see a graph like this and you want to find the area under the curve, break it down into boxes like that. Okay.